Hello, and welcome to the Math 0362 Test 5 review. I hope this has been a good semester for you. Let's see if we can do well on this last exam before you have to take the final. Let's see if we can get a little momentum going into the final. So, the first question wants us to multiply. Square root 3x times square root 2. And really, we would just multiply 3 and 2. So this will be square root of 6x. And that's it. With number 2, we have square root 21 over 100. I could write this as square root of 21 divided by square root of 100. Here's why I do this. The square root of 100 is a perfect square. In fact, it's 10. So your answer is just square root of 21 over 10. With number 3, there's a lot of stuff going on. So let's take the square root of each part. Like 2 is not a perfect square. So this 2 is going to stay in the box. X squared. If you do 2 divided by 2, you get x1. That means 1x comes outside. The square root of 49 is 7, so 7 comes outside. And the square root of y8, or 8 divided by 2, gives us y4. And that's our answer. 4 looks bad, but it's not so bad. What I suggest is divide first. Alright, this 3 on the outside is still 3. We will still have cube root. But 250 divided by 2 is 125. A7 divided by A1 becomes A6. Now it's a lot more manageable. Like the cube root of 125 is just 5. 6 divided by 3 is going to become A2. A2. And I still have a 3 waiting outside. This 3 will multiply to 5. And 3 times 5 is 15. So your answer becomes 15A2. Okay, 5. We like to add and subtract, but right now we cannot. The reason is what's in the square root box is not the same, but maybe there's some similarities. For example, 75 may not be a perfect square, but two numbers that make 75 are 25 and 3. I like 25 because the square root of 25 is 5. And then this 10 that's waiting outside may multiply this 5 to become 50 square root 3. We'll come back to that. 2 square root 28. Well, two numbers that make 28 are 4 and 7. And 4 is a perfect square root. It's 2. But then this 2 multiplies with this 2 over here. And this will give us negative 4 square root 7. And then 2 square root 27. The square root of 27, two numbers that make 27 are 9 and 3. And 9 is a perfect square. It's 3. But then this 3 on the outside will multiply with this 2 in front to become negative 6 square root 3. Notice the first term and the last term. They both have square root 3 attached. So now we are allowed to add and subtract. 50 minus 6 is 44, square root 3, and then minus 4 square root 7. That's our answer. Number 6 is just going to be a FOIL. So first, 7 times 6 is 42, and square root x times square root x is regular x. Then 7 square root x times negative 4 is negative 28 square root x. Then negative 7 times 6 square root x is negative 42 square root x. And finally, negative 7 times negative 4 is positive 28. Once we reach this point, notice we can combine the middle terms. Negative 28 minus 42. That's going to give us negative 70 square root x. And everything else just comes down. For number 7, we would like to rationalize the denominator. Rationalize just means no square roots in the bottom. So let's multiply top and bottom by square root 7. Square roots will multiply with other square roots. So the top becomes 2 square root 21. And square root 7 times square root 7 is just regular 7. And that's our answer. With number 8, in order to rationalize the denominator, we're going to introduce something called the conjugate. Conjugate just means same terms, but opposite sign. So we're going to multiply top and bottom by 5 plus square root 10. And then let's double FOIL. So up top, we're going to do 2 times 5 plus square root 10. And when we do, we're left with 10 plus 2 square root 10. We'll come back to that. For the bottom, we will do 5 minus square root 10 times 5 plus square root 10. 5 times 5 is 25. 5 times square root 10 is 5 square root 10. Negative square root 10 times 5 is negative 5 square root 10. And negative square root 10 times positive square root 10 is actually negative square root of 100. Well, a couple of things happen here. First, the middle terms may cross off. And the square root of 100 is 10. So we're left with 25 minus 10, which is 15. And then the last step is to do top over bottom, which would be 10 plus 2 square root 10, all over 15. Number 9, I'd like to solve for x, but we have a problem. X is stuck inside the square root box. So let's start by squaring both sides. So we get 4x minus 3 equals 25. Now we don't have to deal with square roots anymore. So I will add 3. So 4x equals 28. And then divide by 4. We get x equals 7. And that's our answer. For 10, we're going to do something similar, but first let's add 2 to both sides. I want to get the square root part alone. So we get square root 5x minus 4 equals 4. Now let's square both sides. This becomes 5x minus 4 equals 16. And we'll go through, add 4. So 5x equals 20. Divide by 5. We're left with x equals 4. Alright, with 11, we're going to do the same thing. I'll square both sides. The left side becomes 11 minus x. But the thing is, on the right side, x plus 1 squared means we have to FOIL with itself. So let's FOIL. X times x is x squared. X times 1 is x. 1 times x is also x. 1 times 1 is 1. The like terms may combine to give us x squared plus 2x plus 1. And then from here, let's work on getting things to one side. I will subtract 11 and add x. This gives us x squared plus 3x minus 10. And good news, this factors. X squared becomes x and x. Two numbers that make 10 are 5 and 2. And we can get 5 and 2 to make 3 if 5 is positive and 2 is negative. Once you have this set up, the next step is to split this into two problems. So we'll have x plus 5 equals 0 and x minus 2 equals 0. I'll subtract 5, so x equals negative 5, and add 2, do x equals 2. And there's our answer. For number 12, we would like to find the length of x. And we're going to use something called Pythagorean theorem. And the way that works is we're just going to do 6 squared plus 2 squared equals x squared. 6 squared is 36. 2 squared is 4. If I add that up, I get 40. Now to just get regular x, I would do the square root. And 40 is not a perfect square, but two numbers that make 40 are 4 and 10. 4 is a perfect square, it's 2. So we're left with 2 square root 10 equals x. For number 13, we would like to simplify. Well, any negative in the square root just means I, so I is coming out. And two numbers that multiply to make 54 are 9 and 6. Well, 9 is a perfect square root, it's 3. So in the end, our answer is 3I square root 6. For 14, we're just going to add. First, we're just going to add 2 plus 9, which is 11. And then negative 8i plus 5i. Negative 8 plus 5 is negative 3i. And that's it. For 15, we're just going to FOIL. So 5i will multiply to 3 and to negative 4. 5i times 3 is 15i. 5i times negative 4 is negative 20i squared. But we can go a little further. I squared is the same as negative 1. And negative 1 can multiply with negative 20 to become positive 20. So our new answer is 15i plus 20. 16 will work the exact same way. 2i times 5 is 10i. 2i times negative 8i is 16i squared. But again, I squared is negative 1, which multiplies with negative 16 to become plus 16. So we're left with 10i plus 16. With 17, the square just means we're going to FOIL with itself. So 2 times 2 is 4. 2 times negative 5i is negative 10i. Negative 5i times 2 is negative 10i. And negative 5i times negative 5 is positive 25i squared. At this point, a couple of things are going to happen. First of all, the middle. Negative 10 minus 10 is going to be negative 20i. The last part, I squared becomes negative 1, which multiplies to 25 to become negative 25. And 4 comes down. And then finally, 4 minus 25 combines to become negative 21. So your answer is negative 21 minus 20i. Alright, for 18, we would like to solve using the quadratic formula. But in order to use it, we have to get one side to 0. So let me subtract 6x. So we have x squared minus 6x plus 5. Let me write down the quadratic formula as a guide. Alright. And what I like to do is I like to make a list of what a, b, and c are. A is a number in front of x squared, which is 1. B is negative 6. C is 5. So let's plug in everything we know and get some answers. So we're going to get minus negative 6 plus minus square root negative 6 squared minus 4 times 1 times 5 over 2 times 1. First of all, two negatives just become positive, positive 6. 6 squared is going to be 36. 4 times 1 times 5 is going to be 20. And 2 times 1 is 2. Well, when I work the inside, 36 minus 20, that's going to give us 16. And I like 16 because it's a perfect square. It's equal to 4. When we reach this point, we're going to treat this as two separate problems. 6 plus 4 over 2, 6 minus 4 over 2. Well, 6 plus 4 is 10. 10 divided by 2 is 5. And 6 minus 4 is 2. Divided by 2 is 1. So your answers are 5 and 1. For 19, let's use quadratic formula again. So A is 1, B is negative 6, C is 13. So I have minus negative 6 plus minus square root negative 6 squared minus 4 times 1 times 13 over 2 times 1. Two negatives make a positive. 6 squared is 36. 4 times 1 times 13 is 52 over 2. Well, 36 minus 52 is negative 16. 16 is a perfect square. It's 4, but because it's negative, what we're really going to have is 6 plus or minus 4i over 2. And then the last step, 6, 4, and 2 are all even, so we can divide every single number by 2. So we're left with 3 plus or minus 2i. That's our answer. Let's do quadratic formula for number 20. So A is 2, B is 7, C is negative 4. So I have negative 7 plus or minus square root 7 squared minus 4 times 2 times negative 4 over 2 times 2. Well, negative 7 is negative 7. 7 squared is 49. Negative 4 times 2 is negative 8. Negative 8 times negative 4 is positive 32. And 2 times 2 is 4. Well, 49 and 32 may combine. In fact, they add up to 81. And I like 81 because it's a perfect square. It's 9. But from here, we can treat this as two separate problems. Negative 7 plus 9 over 4, and negative 7 minus 9 over 4. Well, negative 7 plus 9 is 2, and 2 over 4 is the same as 1/2. Negative 7 minus 9 is negative 16, over 4 is negative 4. Alright, number 21. We like to solve using quadratic formula, but I gotta do a lot of things. First, I have to FOIL, and then I gotta get one side to 0. So let's FOIL first. So we'll have x squared plus 2x plus 4x plus 8 equals 7. Well, the 2x and the 4x may combine to become 6x. And I can subtract 7 on both sides, which becomes plus 1. At this point, we're ready to use quadratic formula, where a is 1, b is 6, c is 1. So first we'll do minus 6 plus minus square root 6 squared minus 4 times 1 over 2 times 1. Well, negative 6 plus or minus square root 6 squared is 36. 4 times 1 is 4 over 2. 36 minus 4, that is going to be 32 over 2. Now, 32. It's not a perfect square, but two numbers that make 32 are 16 and 2. I like 16 because it's a perfect square. It equals 4. So we become negative 6 plus or minus 4 square root 2 over 2. And notice 6, 4, and 2 are all even. So we can divide each of those numbers by 2. And what we get is negative 3 plus or minus 2 square root 2. That's our answer. Alright, for 22 we would like to find the vertex. And there's a formula for vertex. It goes negative b over 2a. Well, I know a is 1 and b is 2, so let's make the change. So negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. Now, plug into the equation. So we're going to get negative 1 squared plus 2 times negative 1 minus 8. Negative 1 squared is 1. 2 times negative 1 is negative 2. And then minus 8. And all of that becomes minus 9. So our vertex is the point negative 1, negative 9. Well, that concludes our Test 5 review. I hope this review was beneficial for you. If you have any questions, please stop by the Math Resource Center in ESEE 1112. Otherwise, good luck and have a great day.